Welcome to The Explainer. Today we're taking a whirlwind tour of planet Earth. We'll journey across the continents, dive into the oceans, and explore the very systems that make our world tick.
So, how about a tour of the entire planet in just a few minutes? Yeah, I know, it sounds kind of crazy, but we're going to give it a shot. We'll be condensing billions of years of history into one quick trip, and we're starting with the very foundation of our world, the land itself.
All right, first up, let's get the lay of the land. See, our continents aren't just big, flat chunks of rock. No way. They're these incredible tapestries woven with soaring mountains, massive plains, and deep, deep valleys. And each one tells a piece of our planet's story.
Okay, so how do we even begin to make sense of all these different shapes and sizes? Well, it often boils down to one simple thing: elevation. All that means is how high something is compared to sea level. And that one measurement, it's the key to telling the difference between, say, a beach and a massive mountain.
Take these two for example, a plateau and a plain. They're both flat, right? But their elevation tells completely different stories. Think of a plateau as a giant tabletop, right? It's flat on top, but it rises up steeply from the land around it. A plain, though, that's a huge low-lying area. It's flat or maybe gently rolling, which, by the way, is exactly why they're perfect for farming.
And what do you find nestled between all those high places like mountains and hills? You get valleys. And these aren't just dips in the landscape. Oh no, they are often the most fertile spots on the entire planet. The reason is simple. All the water running down from the highlands carries rich soil with it, basically creating these natural, super fertile farming hotspots.
Okay, so we've covered the highs and the lows. Now let's head for the coast. This is where things get really interesting. That dynamic edge where the huge landmasses of our planet crash right into the even bigger oceans.
So, what's the real difference between a continent and an island? You might be surprised to hear it's really just about size. I mean, think about it. An island is just a piece of land completely surrounded by water. A continent? That's just a really, really big island. In fact, that makes Australia and Antarctica not just continents, but also the world's two largest islands. Kinda cool, right?
And the way land and water meet creates some other really cool features. You've got a peninsula. That's a piece of land that juts way out into the water, almost like a finger pointing out to sea. Then you have the opposite, an isthmus. That's a skinny strip of land that acts like a bridge connecting two much bigger chunks of land. The most famous example? Probably the Isthmus of Panama, which links all of North and South America.
But hey, the coastline is just the beginning. Let's take a deep breath and dive under the waves, because we're about to explore the hidden world of the ocean floor. And this isn't some small feature. This realm covers more than 70% of our planet. You know, if you could just pull a giant plug and drain all the oceans, you wouldn't find a smooth, boring, sandy bottom. Not at all. You'd find a landscape that's every bit as wild and dramatic as what we see on land, with huge mountains, vast plains, and deep canyons, all shaped by the exact same forces.
And some of the most extreme features you'd find down there are trenches. To get a picture, imagine the Grand Canyon, but now make it way, way deeper and plunge it into complete, total darkness. That's a trench. Just these massive, steep-sided gashes in the ocean floor.
And the scale is just mind-boggling. The Mariana Trench, for instance, is over 35,000 feet deep. Let me put that in perspective for you. If you could take Mount Everest and place it at the bottom of the trench, its peak would still be covered by more than a mile of water. Wow.
Okay, here's a fun fact that might just blow your mind. What's the longest mountain range on Earth? If you said the Andes or the Himalayas, you'd be wrong. It's actually the Mid-Atlantic Ridge, this enormous underwater mountain chain that runs right down the middle of the Atlantic Ocean. It's almost completely hidden from us, but it's there.
So we've seen the incredible landscape under the water. But what about the water itself? Let's pull back a bit and take a look at the stuff that actually makes us the blue planet. You know, we call Earth the blue planet for a reason. It's covered in water. But here's the catch, and it's a big one. A whopping 97% of all that water is salt water. It's in the oceans, and for us and most land animals, it's totally undrinkable.
So that leaves just a tiny 3% as freshwater. But wait, it gets crazier. Most of that freshwater is frozen solid in glaciers and the polar ice caps. So when you actually do the math, the water in all the lakes, all the rivers, and underground that we all depend on to live, it makes up only about 1% of all the water on the entire planet. Just 1%. So, if the fresh water we need to survive is that rare, how does anything on land even exist?
How do we have enough? Well, it all comes down to this absolutely brilliant recycling system that our planet has, which is constantly cleaning and moving that precious water around.
And this is a thought that just floors me every time. The total amount of water on Earth has pretty much never changed. It doesn't get created or destroyed. It just gets recycled. That means the water you're drinking right now, it could have been part of a cloud that rained on a dinosaur. It's all the same water, just moving through this amazing, endless cycle.
And the whole thing is powered by the sun. It works in a simple three-step loop. First, the sun's heat causes evaporation, turning liquid water into vapor that rises up. Then, as that vapor gets higher and cooler, you get condensation. It turns back into tiny droplets and forms clouds. And finally, when those clouds get full, you get precipitation. Rain, snow, whatever, and the water comes back down to Earth, ready to start the whole journey over again.
But here's the thing. This seemingly perfect system, it's actually really fragile, and our activities can throw a major wrench in the works. When we introduce pollutants, they get sucked right into that cycle. Factory pollution can contaminate rivers. Chemical runoff from farms can poison the water underground. Even pollution in the air can mix with the water vapor and come back down as acid rain, which can mess up entire ecosystems.
So, as we've seen, everything from the tallest mountain to the deepest part of the ocean is all connected by this constant journey of water. It's this one huge, intricate system. And knowing how it all works and how delicate that balance is, it leaves us with one really big question, doesn't it? What's our role in protecting it?